Hi, good morning, good afternoon, everyone. Thank you for joining me today. Today we are talking about, as introduced, frequently misunderstood foundation design provisions. This is what I would call a bit of a grab bag topic that we're going to cover quite a few different aspects, but they're all related to foundation design. And in general, this is going to encompass both things that we observe in practice that may not get implemented correctly or may be commonly misunderstood. Some of these things are code changes that have recently occurred or are occurring that you should be aware of that would affect your practice. And other things are just observations and lessons learned on projects that would be beneficial to share with the group here. So with that, so the summary of topics that we're going to cover today, first is we're going to talk about load combinations for foundation design and some of the nuances in understanding and implementing load combinations, and specifically how those are changing with current code changes that are occurring. We're also going to talk about liquefaction risks, how to address them, either how to design for it inherently or how to mitigate liquefaction risks for structures that are subjected to liquefaction. After that, we'll have the first break. Then we will get into basics of soil structure interaction and how it relates to typical design parameters and typical projects, and many things that I think will benefit your practice without having to get too deep into the world of soil structure interaction. We'll start a little bit on map foundation design, and then we'll take the second break. We will then finish map foundation design and talk a bit about deep foundation detailing and some clarifications and things that are commonly misunderstood there. So diving right into load combinations. So I think everyone understands that when you enter the foundation design world, you need to use both allowable stress design and LRFD load combinations when you're designing a foundation element. And at least as for current practice, what would commonly be done is you would use allowable stress design, which I'll use the term ASD moving forward. That would be used for sizing the soil foundation interface for spread footing. That might be just checking bearing pressure under a spread footing. Or if you're talking about a deep foundation element, it may be checking skin friction along the length of a deep foundation. You're also commonly going to use allowable stress design loads when you're talking to a geotechnical engineer. Many times they're working in the world of service level loads and not necessarily in the ultimate strength design world. And then conversely, when we're talking about load resistance factor design or ultimate strength design, those are commonly used for obviously anything that's designed in concrete in ACI 318, for example, sizing flexural reinforcement in a shallow foundation or a drilled shafts, or designed for shear reinforcement in a shallow foundation or checking punching shear. So what I see is frequently misunderstood as not understanding the correct application of these load combinations, where to use which combination. Specifically, there's a lack of understanding of the two options for allowable stress design, which I'll go through. And then the other complication is when you introduce seismic load effects, there's many nuances to how you apply that and add that to your load combinations that I find many engineers are overly conservative in the way that they account for that. So first is just a summary of the three types of load combinations that were essentially introduced in the previous slides, but everyone is familiar with strength design. You recognize 1.2 dead, 1.6 live, for example. For seismic, a low gravity combination of 0.9 dead plus 1.0 earthquake. So the first type of allowable stress design load combination is called the basic allowable stress design. And this is, in brackets here, is a code reference to IBC 2012 in this case. It's essentially unchanged in 2015. But so 1605.3.1 would send you to dead plus live. That's obviously one everyone's familiar with. And then the low gravity combination for the basic ASD case is 0.6 dead plus 0.7 seismic. So that essentially converts the seismic load to a service level load. Now there's another type of allowable stress design combination in the IBC, and this is called the alternative basic. And you'll recognize dead plus live as the same, but what's fundamentally different is the low gravity overturning combination. And so that actually has a 0.9 dead plus E over 1.4. So E over 1.4 is essentially the same as 0.7 E, but 0.9 dead is obviously very different than 0.6 dead. So first I would compare the LRFD and the basic ASD load combinations because those are taken directly from ASCE 7. You'll notice that in ASCE 7 you don't have the alternative basic load combinations. So the good news is that the LRFD and basic ASD are generally consistent when you're talking about the overturning factor of safety.